welcome to today's Jones Seminar. It's really a pleasure to welcome you here on a rainy day, and especially to introduce our local speaker, Chris Levey, who's well known to many people here, most people here, I would guess, who's Associate Professor and Director of the Microengineering Lab. Chris, it's really a pleasure. I've asked him at the last minute to speak, so I apologize profusely to him, but I know that he has really exciting stuff to talk about, and I think I can see that there's a lot of interested people in the room here. So this is kind of an impromptu invite, but well-deserved. Chris has presented on the use of makerspaces and facilities for project-based learning at several educational conferences, including ABET, MS&T, ISAM. Chris is known to us as the director of the Thayer School Microengineering Lab, having expertise in microfab techniques, microrobots, microoptics, microinductors. He's been here at Thayer School for a long time. I'm not totally even sure how long, but maybe he'll tell us. He hails from a BA in Carleton College, PhD at University of Wisconsin-Madison, and spent 2 years at Bell Labs before coming to Dartmouth. Worked at the physics department as a faculty member prior to coming to Thayer, and has been here for a number of years now. But the most important thing today is that Chris has been extremely active in really leadership level of designing and helping people think about what to do in construction and space planning. And so that's really what he'll be talking about today: purposeful design for project-based engineering, new Dartmouth West End buildings, or what I would actually preface this talk as what's going on with the big hole in the ground in our former parking lot. So Chris, thanks very much.
Thanks for the kind introduction, and to answer your question, I came to Dartmouth in 1986 and saw the light and moved to Thayer in 93. So I appreciate the opportunity to talk to you this afternoon about the new buildings that are going to be going up on either side of us here, and in particular, my view on how we design such buildings for their function. And one particular function I'm going to use as an example is our project-based engineering. And you can see here some examples of projects, whether it be a line-following robot car or a new design for an ergonomic serving tray, or something to help the blind that scans in front of you and sends signals to a blind person. Many, many, many of our students learn through projects. But before I start, in honor of Dartmouth's 250th and Thayer's just a couple years ago 150th anniversary, here's a little prequel. This is early 1939 construction of Cummings Hall, the building that we're in right now, although not this part of it, and wings added to Cummings Hall in 1947, and then the center part filled in and an extension added to the west and the pavilion added to the east in 1990. That's the part that we're in now. And since Old Tuck Drive is key to this whole West Campus planning, the reopening recently of the drive, I thought it'd be fun to throw in a slide of the construction of Old Tuck Drive. I don't know that, but I'm guessing it was probably called Tuck Drive at that time. So here's what it looks like now, or almost what it looks like now. Here we are in Cummings Hall, and off on the other side of this door is MacLean. And we have two sites. The Thayer and Computer Science building will be in this region, and the Irving Institute will be between us and the Tuck School. But of course, this isn't really what it looks like right now. This part right now looks like that. Or actually, that was yesterday. It's deeper today. So plans for buildings are not done in a vacuum. We have a master plan that sets the scene for this neighborhood. The West Campus Master Plan looks not only at the Thayer Computer Science site and the Irving Institute for Energy and Society site, but also 3 potential new sites that are where there are some dorms now, with the West End Green remaining as the focal spot between them. And that master plan also would love to see a path from the green to the blue. That's not happening right away, but we'd love to see it at some point. That would involve a bridge going through the cemetery. But you can see how that would connect our end of campus very nicely to the rest of campus and to the Arts District in particular. So I'm going to start by looking at the plans for the 2 buildings so you have a perspective before we start looking at how we get to those plans. So the Thayer CS building here will house not only the Thayer School of Engineering, but also the Department of Computer Science and the Magnuson Center for Entrepreneurship and the Dartmouth Electron Microscopy Center. These are facilities that are going to really enhance what each of us do. This co-location will be valuable to each of us. Provost Helbley has said of this new building that the dynamic environment that it creates will help synthesize collaboration, entrepreneurship across a broad array of disciplines, including medicine and energy, 2 key disciplines for Thayer School, security and robotics, 2 key disciplines for computer science, electronics, particular power electronics, a key discipline for Thayer, and product design. And Joe spearheaded, really, this entire project many years ago as Dean of Thayer School. On the other side of us, to the north, will be the Irving Institute for Energy and Society. This is what it will look like coming down Tuck Drive or a little closer at Tuck Circle. And the mission statement for the Irving Center looks for a vibrant collaboration across all academic disciplines in preparing the next generation of experts for the world's energy challenges. So here's my question. Does building a building like this or this, does the design of such a building play a role in how we educate our students in order to become leaders, innovators, and experts of a world class? What does building design have to do with that? And my example, well, I will say first that interwoven research and teaching missions are key to that, both sides. I'm going to give an example from the teaching side, and my example is going to be project-oriented curriculum. So why is it that in engineering sciences, why is it that we would like to have a open-ended project-oriented curriculum? We believe, and research shows, that hands-on experiences are very valuable to learning. Students set their own problems and they learn from their own mistakes. There's a higher motivation when you have set your own problem. Students are willing to work many hours into the night on something that if it were just a homework assignment, they'd probably give up a lot earlier. And the learning is retained better if it's something that you believe in and are working on. We run most of these projects as teams, and that means that students are also learning teamwork skills. They're learning project management, and they're learning project planning. And they're applying the fundamentals, the engineering fundamentals to real-life examples. These projects can be oriented toward design of products or improving the engineering of things, or they can be oriented toward a scientific, systematic study of a system, like how does a change in processing of a material system change its microstructure, and how does that change its properties, and can we design the properties that we want in that way? So what characteristics would we like to have in a building that would help to facilitate this kind of open-ended project? We certainly want the spaces to be friendly to interactive use. We'd like them to be cross-disciplinary spaces. We don't want to design our spaces for disciplines. We'll divide the spaces up by the kinds of needs that are in that space. A space may need to be really clean, or it may need to house really dirty projects, messy projects, projects with fumes. You need better ventilation. Some projects may be big and clunky. Some may be small and delicate. They might want to be in different spaces. Some might be quiet. Some might be noisy. That's how we want to divide up, not by electrical engineering over here and mechanical over there, because we want our students oriented in one direction to learn from students oriented in another direction. That's why we don't have disciplines within Thayer School. We're one school. We would like to have the tools and equipment that are needed be somewhere nearby. We'd like to have mentors nearby for the students. That means the spaces need to be clustered. We'd like to have really good lighting in spaces where assembly is done. We'd like to showcase the results of student projects, because students learn not only from each other during in a team during a project, but they learn from seeing what other students have done in the past. So we can do all of that without specialized spaces. In fact, Thayer has been done project-oriented engineering since at least the 60s, probably before that. But we can do a little better if we have the right spaces. In 1999, several of us got together and said, what would we really want if we were going to do this project-based curriculum right? We'd like to have a space that has these sorts of things in a big showroom with all of the things you need close by. And we said, well, what would that take in Cummings Hall, which is the only building we had? We said, well, in the pink here, it would take most of the ground floor, except for the room you're sitting in right now, room 100. It would take most of the rest of that. So we went to the dean, Lewis Duncan, and said, hey, what about this? And he said, no way. I'd have to kick out all these researchers. But, he said, how about a new building? That building, MacLean Engineering Sciences Center, opened about 8 years later. So the vision statement for MacLean, and I'm not going to read this whole thing, but key to the vision statement at the top there in the blue, integrated project labs to support multidisciplinary design and hands-on discoveries tools. Another side I'm going to talk less about, but I feel equally passionate about, is that the classrooms allow interactive learning. Studio classrooms, collaborative and active learning classrooms. I would add to that vision statement some additional building design criteria. Thayer School is one school. All of our buildings need to be as intimately connected as they can be. So we need it close by and lots of connection between that. We value interactions, random interactions in the hallways. So planned inconvenience, putting professors' offices away from their labs, making the coffee somewhere else, is really important to enhance those encounters. And we want Thayer to retain its mix of all functions in all buildings. So certainly we're not going to build an electrical engineering building over there and keep mechanical engineering here. We want all different disciplines. We want all different functions. We want different types of spaces, classrooms and labs and student spaces and faculty offices and administration, all of those things mixed in all of our buildings. So I'm going to give you now an example of project labs that we developed with those criteria in mind in the MacLean building that we've already built, because with that example, I can tell you how it worked. So this is the Couch Project Lab in MacLean, and you can see there are lots of materials here. There's some metal stock, some wood stock, lots of springs and bolts and nuts, a place for photography, lots and lots of foam core for constructing things like this. And there's a little video here. It doesn't, hold on, I have to tell it to play, I think. All right, so that's just a couple hours. You can go online and see 24 hours of use of the Couch Project Lab. It goes on like this until like 4 a.m., and then it's quiet for a little bit before the custodians come in. Here's another photo of the Couch Lab in use. You can see students are working with each other and learning from each other. And that's really what project-oriented curricula is about. So Couch Lab is not the only central home space for projects. We have three. In the Couch Project Lab, which are these bottom three photos, we have assignable cubbies. And the idea is that look at how empty this table is. That's amazing to find a table that empty. But it's not that amazing because that's our strategy with Couch Lab. Every morning we have a TA come in and sweep everything off the tables off into a big bin. And the students have to go reclaim their parts in the bin. Boy, they learn pretty quickly that they put their stuff away into cubbies. But that means there's always space to spread out, and that is ever so important if you're trying to work on projects. But not all projects can be done that way. Not all projects fit into one of those cubbies. You can see a couple of the cubbies here. The walls with cubbies actually aren't shown in these. So some projects need an assigned space for a term or two terms, and that's what we use the Fahey Advanced Project Lab for. You can see you get an assigned workstation, and by the end, this is what it might look like at the beginning of the term, and this is what it might look like at the end of the term. And you can see that wouldn't work in the Couch Lab, but since this is assigned to a particular group, that's their problem, right? This is for reasonably small stuff, but sometimes you need to assign a space for something that's really big and clunky. And for that, we have the Allen Large Frame Lab, where instead of assigning workstations or cubbies, we assign carts, wheel-around carts. So you can see there's a car on a cart here. It's a little hard to see, and a car on another cart here. But it's not just cars that we build. We could build a $100 home. We could build a bamboo structure. We could work on mattresses, anything that's big and clunky, things that might need to be welded or nailed together. So here's a look at the floor plan for the MacLean and Cummings on the ground floor, which connects through the atrium. And you can see pathways are really important, connections between labs. So as part of designing these unified project labs, we said we want to have central spaces. We have three of them. We have the Fahey lab I just told you about, Couch Lab, and the Allen lab. Those three different kinds of central spaces. And we want to have lots of satellite spaces around them that allow students to do what they need to do next before they come back to their home space. And we need connections between those. But as we looked, when we were planning MacLean, as we looked at how much space we would need to do all this, you could see in Cummings, even at that point, we were going to take a whole floor. And by the time we added what we wanted with MacLean, it was more than the floor plate of a single building. So it was clear we had to use both buildings, and the only floor that connects everywhere for both buildings is the ground floor through the atrium. So that said that this had to be on the ground floor, and that's what we did, as you can see. And so let's look at how the layout reflects the workflow for this. So if you start out in the Couch Lab here, building concept models out of foam core and wood and saying, how would this work? It's not real yet, but how would it work? How does it fit together three-dimensionally? You can brainstorm, build a concept model, and then go over to the CAD lab and build a virtual model. From that, you're ready to go to the machine shop and the fab lab and make the parts that are needed. And then you can come back to your home base, be it Couch Lab or one of the other two labs, and assemble those parts and see how it really works. It won't work well the first time, so you go back and you iterate many times around this loop. And if you have electronics, you go next door to the electronics project lab and build your circuits. If it needs to be painted, you go to the high airflow lab where there's a paint booth. If you need parts or equipment, instruments to test it, you go to our lending library where you can check out equipment. If you need a furnace to heat treat some steel or something, you go to the materials lab, or if you need to see under a microscope, you come to the microscopy lab. So you see how all of these are satellite facilities around. The asterisks are particularly important. This is where the mentors are. These are the people who can advise students, and they're scattered throughout this facility. And just to give you a sense, I've shown here in the outline the size of a football field excluding the end zone. So that gives you a sense of what kind of space we're talking about for dedicated to project labs. It's less than that, of course, but you can see it's becoming of order. As I said, human resources are really the key, much more important than the space itself. But by designing the space right and putting the people in the space in the right places, we can do a better job. And Thayer faculty are incredible about designing and supporting project-oriented curriculum. But I want to give a shout out here to all the other people who help with our project-oriented curriculum. All of these people are not well, actually I'm on there, but except for me, all of these people are not faculty members. They're here to support this side of our curriculum. And you can see that we have this poster here so students know where they can go to help. This poster is up in the project lab, and it shows you that for help in a particular area, like this area, you can go to anybody in this green section.
Not to scale mock-up.
Here's an example.
Walking soccer playing robot. The members are Dan McGoon, Dana Weiland, Rachel Margulies, and myself, Ned Feist. The nice part about having all this foam core and servos and the speed controller and the receivers and all that other stuff now is that we can test design concepts before we put anything in CAD or make anything out of more permanent materials.
Oh, cool. And I didn't get back to film his final version, but there is a picture of it, a photograph of it. And this is the group of students that was working on that. I'm going to give another example here. This is an example where students go to Couch Lab, and they are presented with a challenge in the next hour and a half to invent a device, an electronic device, to build it and to demonstrate it to your colleagues. And they are given choice of hundreds of sensors that are available. These are little tiny modules, sensor modules, that are available in the Couch Lab. And they're given an Arduino and a shield that helps them with that. And they're told to choose a sensor of interest to them and try it out. And we give them some sample code so it makes it easy to try it out. And then we say, put that aside, and now choose an actuator, something that does something. So, a sensor could be a button, an actuator could be a little pinchers, right? Or it could be a buzzer. And then their challenge is to put these two things together so that, as an example, you'll see in just a moment, if you have too much alcohol on your breath, the pincher pinches you. That's a student example. But by hundreds of sensors and actuators means that the number of permutations and combinations is huge. So they all do something different. And, oops, I still have to start this one too. Over here is the personal masseuse.
Awesome. So for ours, we want it so that you have two different vibrators on your left side and your right side. So it's voice activated. So say left or right, a little light's going to turn on and it's going to vibrate that shoulder versus the other one if you have a big stressful day, especially in 21, you know what I'm saying? So high cell, left. So vibrating. High cell, right. There he goes. High cell, stop. So.
Great.
Yeah, so if there's too much alcohol, then it'll open and close.
Here are your pinchers. Doorman!
We built something that when it gets above a certain temperature, the fan will automatically turn on to cool stuff down. And then when it gets back below that temperature, the fan turns off automatically.
So normally it's sitting and then someone tries to steal the valuable goods, makes a tone and lights up.
And how does it know?
It's sensing the X accelerometer value here, and we've thresholded it such that a slight impact will trigger it.
Okay, so our project is silent but deadly. It is a CO2 sensor and an LED light. And when the CO2 levels go above a certain threshold, the LED light turns on. You can see it go up. Once it goes past.
What's it reading?
Yeah.
Oh, all right. All right, so building design, as I said, we look at circulation, how various components connect to each other, here and here. Sometimes you plan for the future. It turns out this is an early plan from MacLean, and the connection right here is exactly the connection we're going to make to the next building. You go through blocking studies. You say, hey, is this going to fit in its neighborhood? You do many iterations, just as students do in their design. On exterior, you can see this is a version of MacLean that's not the one we built. And on interior, this is different than the actual atrium that we built, but it's close. And sometimes your ideas don't get built right away. With MacLean, we had planned a parking garage underneath the parking lot. That didn't happen, but guess what? That's exactly the place it's going to go now, and it was going to be built for a building to go over top of it, and we're putting a building over top of it right now. So here's MacLean under construction, August 2005, and here it is finished. Well, sort of finished. A few years later, we said, oh my goodness, we're out of office space, but we had in designing MacLean, we had designed it to take an overbuild on the top floor. So we've added another 12 offices there and also added photovoltaic panels. So that was episode 2, MacLean. Episode 3 is the next Thayer CS building. So we start with a basis of design, asking, well, who are we and how can we build on our strengths? And we look at what our strengths are: engineering and medicine, energy technologies, complex systems, and where they overlap. And we have meetings scheduled on different days where groups study those themes and what would be needed for them. And we do blocking studies to see, hey, does the mass of this work? And we say, oh my God, if we're going to make a building that doubles the faculty, it's going to look massive in this neighborhood. It's not going to work unless we break it up and make it look like 4 buildings from the outside. And you can see in the end, that's what's done. So let's take a quick tour. Here's inside the new Thayer CS building. The front door is over here at the ground level. We're going to start down here at what we call the garden level because off the side over here exits like a walk-in basement, exits to a beautiful patio area in the back. So we're going to start down here. you can see Couch 2. Hey, we have a new project lab, and it's going to be named Couch 2. So we'll start in that corner over here. And just to get you oriented, here are all the floors, and this is, as I said, the garden level. And so we're going to start in this corner, but first I'll just point out that in addition to Couch, there are lots of opportunities for projects going up the stairs to the makerspace or studio, classroom, couch lab, across to MacLean. It's a straight flight of stairs back to Couch 1. There are some small classrooms that can be used for projects. There's a computer lab here that could possibly be used that way as well. So here I am now looking at just this corner of that floor, and you can see the layout for the couch lab and a studio classroom that we can open up to make it double the size if we want to have a big workshop in that kind of environment. One of the things we're going to do with Couch 2 is allow professors to schedule their regular classes in the lab. We've had lots of requests to do that in Couch, and we usually say no because students have to have a place to go 24/7 to work on their projects. But now we'll have 2 such labs, and we can schedule this sometimes for classes. Sometimes it'll be open, sometimes it'll be a class in there. And these can, just as next door, Couch 1, they can spill out into the atrium. These projects can. I'm going now to the northeast corner, this corner. We were at that corner before. And that's where the Electron Microscopy Center for Dartmouth will be. It's used a lot in Thayer research, but it's used throughout the campus. And we're happy that we'll be having lots of visitors from up campus to our facility here. In addition, we have material science related work going on here, 3D printing of electronics and physical vapor deposition and some computing methods in materials, and a classroom, and grab-and-go food. Everybody likes food, so I thought I'd throw some slides. We don't know for sure what it's going to be like, but it is going to be a secure space where you can take your Dartmouth ID and go in. There'll be cameras there, and it's a self-checkout system. It might look like this. It might not. But it'll be nicer than normal vending machines. So let's now go up the stairs here to the first floor. On the west side, on that side, it's design-oriented. You can see here design faculty, design loft, some classrooms, and then experiential design. So this is an element of our program that we want to grow. And this is the space for that. On the opposite side, on the east side, near the entrance right here, that's the front door entrance. Near the entrance are the Magnuson Center for Entrepreneurship, the DALI lab, Dartmouth Applied Learning and Innovation Lab, and a makerspace. So DALI lab is another example of project-oriented education. Students learning how to write apps for phones, learning how to do digital art, that sort of thing, typically in groups, and producing a product. Computer science, mobile devices research. So this is a research lab here and here. You can see here is the stadium staircase with lots of breakout space on it that goes up from the couch lab to those spaces, Mobile X, the Makerspace, DALI, and Magnuson Center. Let's take a little fly-through tour of this. Is that gonna? It's not gonna. Oh, it's not. Oh, I did. Sorry. There we go. So you recognize MacLean. This is the front entrance to the atrium. Now you see the front entrance to the Center for Engineering and Computer Science. Notice that the bridge covers 3 floors. It covers 2 floors up here, and there's a tunnel that covers a 3rd floor underneath. Heading around the east side. Underneath the ground over there is the Electron Microscopy Center, where it's shielded from the cars and shielded from vibration. South side. This is that garden patio that I talked about. That's why we call that the garden level. Couch lab is in this corner, not in the corner, but off this side right here. There's the parking garage underneath the whole thing. I haven't talked about that, but yes, there is a parking garage under it. And here you see MacLean, the side of MacLean. Thayer Drive runs right through here now. This will be pedestrian and emergency vehicles, occasional maintenance vehicles, but not general traffic. So now we can head inside. So there's the Magnuson Center for Entrepreneurship, the DALI Lab, the Makerspace, lots of breakout spaces on all floors. Stadium staircase. The project lab will be on our left over here. I don't know if it's going to show, but that's over here. So I showed you the bottom two floors. Let's take a look at the next two floors. This is the first floor, called level 1. There's an 80-seat TEAL classroom. TEAL, Technology Enhanced Active Learning. So the idea here is that we can set this up as a normal classroom of rows and lecture, but much more importantly, we can set this up as groups of students who are working with each other, each have their own large monitor to project what they're working on together, and a faculty member can wander between them and give advice, and then at some time they can present to each other. So that's an 80-seat classroom. Computer science theory research group, robotics research group. And this side is biotechnology, and it involves both computer science and Thayer School, one of those areas where we're closely interweaving. We're going to use the same core facilities, and we each have labs. So there's a protein design lab from computer science. There's a computational biology lab from CS. There's protein engineering and evolution and immune response labs in Thayer. Notice the bridge over to MacLean. And on the top floor, level 2 or second floor, again, computer science, security, machine learning, and visual learning on the east side. And on the west side, energy technology, ethanol from biomass, and energy technology new hire, room for more biotech new hires. And we actually have a space here that's shelled out for a new hire. When we built MacLean, we left several labs just as shells, and we filled them in with the equipment needed as we hired the faculty, and that worked very well. In fact, we filled in the last one only a couple years ago. Okay, so let's look at the Irving Institute. So the Irving Institute bridges Thayer School with Tuck. Here's what it looks like from the corner of Cummings. This is, for those of you who know Cummings, this would be like from Cummings 105 classroom, or if it's the corner of Cummings if you don't include the pavilion out front. So you could be looking from a window of C105, and this is what you would see. This is the door that many of us use all the time to get to Tuck Circle. The pavilion, again, is down over here somewhere. In the corner here is a cafe. Hey, how convenient for Thayer and CS, huh? All right, so right out the door here and in there and around the corner, and you're in the cafe. And the project lab is right here. I didn't tell you. There's a project lab in the Irving Institute as well. So let's do a video walkthrough of the Irving Institute. The cafe is over beyond this. This is looking toward Feldberg Library. You can see the remnants of the outside, the exterior of Feldberg. Back in there is the cafe. The servery is sort of hidden from this video. Front entrance is right here, facing east, facing up toward Baker. This is the project lab here. Again, we can spill out from the project lab into a larger space. This space can be rearranged in the same way that our atrium is rearranged. Right now, there's an event going on in our atrium. And this corner may have something special or may not. It's not clear whether that's going to look like that, but it will at least be curved corner there. You can see into the project lab a little bit here. So here's the layout. Here's the entrance from Cummings, or here's the front entrance that points toward Baker. So if you come in from Cummings, you can come around to the cafe here, or you can turn left. That's the lounge area. Here are the project labs. So what's different about a Thayer project lab and an energy and society project lab? The project labs at Thayer are cross-disciplinary, but they're cross-engineering disciplines. The project labs at IIES we see as being cross-discipline across all Dartmouth disciplines. So, for example, some undergraduates and a couple of graduate students could be gathered in the project lab looking at a micro-turbine blade that was fabricated at Thayer School, and then clustering around a whiteboard. And on that whiteboard, they would be making notes and decisions relating to political climate and land tenure issues and social acceptance and economic viability, not just engineering issues, as well as hydrological resources and building materials and that sort of thing. And they would be students from many different departments, from economics, from sociology, anthropology, from environmental studies, and from Thayer School and from Tuck School, all coming together in this central facility. So that's what's different about a project lab. It's the same idea, but it's even more broad. Here's a view looking from Feldberg Library toward the front entrance and out the front entrance to the Baker Tower. Here's your project lab. Another stadium staircase. I guess we like that idea. Above this are some offices, and behind the offices here are research labs. And we project that Thayer School will have 2 of the 4 research labs. They'll be here. This is the floor that has a bridge over to Cummings, and so you can't read this in this light. It says our MEM program here. So this is where our Masters of Engineering Management program is, and that connects very nicely to this floor where we'll have some faculty offices and 2 labs, probably in power electronics and how that relates to energy. I hope that I've given you a flavor of how these buildings work and how they may accommodate our program, the style of our program. I should say many people have been involved in the design of all of these buildings. The architects involved, Coder Kim, wonderful architects, were involved in the construction of MacLean. Wilson, also wonderful architects, are involved now in the Thayer CS building. BBB, Beyer Blinder Bell, were involved in the West Campus planning and some very early work we did at studies on whether the Irving Institute of Energy and Society would even be a feasible thing. And KPMB early on, and now Goody Clancy Architects are designing the Institute. The Dartmouth Planning, Design, and Construction Office, in particular John Sherding, has been involved in much of this, not back in MacLean days, but much of this now in a wonderful way. Their Board of Overseer Advisors now has been involved. And faculty members, too numerous to list, but I am going to call out a few. For MacLean, Bill Lotko, Peter Roby, and Dean Duncan were reasonably heavily involved, as was I. And for Thayer CS, and I apologize, I haven't listed all the CS people there. There have been, Hani Farid should definitely be on this list. Let me apologize for that. At Thayer School, the people involved are Joe Helbley, Ian Baker, Chris Cook, Mary Kay Brown, and, as I said, many other faculty, staff, and students. And I need to acknowledge that this project work is enabled by our faculty, but also by our staff, as I said earlier. And this, again, is the staff. In particular, Kevin Barron, a lot of the introduction to resources Kevin and I have developed together. He's been really instrumental in that. He is the manager of our machine shop. So, these are very nice looking buildings, you can tell. Here is Thayer CS, here is IIES. I think we can agree they both fit in the neighborhood pretty well. We can enjoy the exterior characteristics of these. But the real test for success is going to be in the creative work that happens inside the buildings and how its outward and what its outward impact is on the world, right? And we won't know that for a number of years for the new buildings. But we do know we're sending out students from our current buildings that are doing good things. But only years will tell whether we fulfill Sylvanus Thayer's mission to prepare the most capable and faithful for the most responsible positions and the most difficult service. Thank you.